Dear students, let me welcome you to the knowledge series with respect to the continuing chapters related to the fuzzy sets. We have already seen this particular segment on the fuzzy, where we have mentioned that fuzzy is a particular form of a set where we try to give an input from a unprecise conditions, or where the ambiguity or the uncertainty rises. From there we try to collect the inputs and then we try to give it to the fuzzy logic sets or a fuzzy logic controller, where this fuzzy logic controller will try to convert the given crisp set to a fuzzy logic set which consists of a membership functions, and thereby it converts back to the crisp set. Based on that, we go to the next segment. Here we discuss about the basics of the crisp set theory. What exactly this crisp set theory is indicating. If you try to see across this particular segment, you can see that there are different sets is being shown over here. The universal set. The universal set means it's a set containing all objects or the element and of which all other sets are subset. That means you take an example, A is equal to 1, 2, B is equal to 2, 3, 4. So universal set is a combination of these and these, or a union operations of A as well as B. That is what it is been shown across this Venn diagram. This type of a diagram is called as a Venn diagram, where U is termed as a universal set, where the universal set is a union of A set as well as B sets. So these all the elements of A and all the elements of B, it is there inside the U, so that the U set consists of both A and B. Next is the set. Set is an unordered or a collection of an object known or it is a well-defined structure of element is a part of the universal set. So when we term as a set, it may be a order set or it may be a unordered set, but we say that it's a collection of object, either it defined for that universal set or it is not related to the universal set. So we define here in terms of a Venn diagram, A1 in terms of a diagram. Let's consider A1, A2, A3 like this AN, and there are some B1, B2 outside this one. So if that is the situation, we say that all the element of A1 or all the element of AX it belongs to A, and all the element of BX which is outside this set is not belongs to A. So an element A belongs to set A is satisfying that conditions, because in that case A is the universal set for that elements that is being taken. A Venn diagram that shows all the possible logical relationship between a finite collections of different elements. So when we or elements or sets, a Venn diagram shows all possible logical relationship of finite collection of different sets. So if this is a sets, this is a sets, and all the element belongs to A, all the element belongs to B, then we term it as a union operations. And if there is a common element which is there in A and B, then we term it as intersections. So this is being represented in terms of a Venn diagram using if a given condition is given, A union B or a B A intersection B, then in that case we have to represent in this form. Cardinality. Cardinality of a set, it is a set that measures a number of element in a element of that set. So if you say A has only one element, that is a 2, then we say cardinality is equal to 1. And if you say if this A is shown 2, 1, 3, then there are 3 elements in the set, so we can say that the cardinality is 3. And cardinality is shown in terms of these two lines. Null set. Null set means there will not be any elements. So a null set, if is shown like this one, then we say that there is no element. So it is, or it is a phi. Singleton. Singleton, it is also known as a unit set, is a set that which exactly one element. So if you have only one element, then we say this is one element. So we term it as a single tone. So if it is a, even if it is a 0, it is a one element. So or a b is equal to 2, b represented in terms of a curly bracket, and then we termed it as a single tone. Subset. When A is a subset of B, that means A is a part of B. That means A is having a relations with respect to that B. So that's why A is a part of B. Superset. If additional element is added to a set, then it is become, so another set becomes a super of the previous set. Power set. All the possible sets, that is a power 2 to the power of n. If there are n element in the sets, so power set we define in terms of a 2 to the power of n. So these are certain different type of sets conditions in the case of a crisp set. Now coming to the power set, the next continuation. Power set means that it is a set of all subset of a set. Say for example, A is given in terms 1, 2. So if you see the cardinality, what is the cardinality? 2. So the subset of A is what? What I have in all the subset of a set. So if you see A has A can be a subset, means it has a phi, that means a null set. It is a 1, 2, and both the combination 1, 2. So there are 4 possible values. So these are the 4 sets. And what is the power of this one? Power of this one is, again we define in terms of n of power of A is the type, but it is 4. So that is a set of all subset. So that is the number of subsets is called as a power set. So that is what we termed this. Now n of p to the power n of pa, that is the number of power set is equal to 2 to the power of n. So that is what we define. Since there are the cardinality is 2, so we don't say in terms of a cardinality, but since we are saying that there are 2 elements, so 2 to the power of 2 means there are 4 possible combinations. That is what we say as power set. Classical set. Classical set is defined as, suppose A is defined as there are red man, tree, 0.5, 5. So these are color. This is human. This is trees. This is numerical decimal number, and round number 5. So this is these are the number certain elements is being shown. So this element, if we term it as x, then, and if this A is we say that these are the part of A, then A is a inverse of discourse, then x belongs to A. Or if A is a set, then we say that this element which is termed as x, it belongs to A. Crisp set. Crisp set we term as crisp set are the set an element in either a member of set or not. So when we say a crisp set, let us take these are x1, x2, x3 up to xn, a part of x. So x is a set where these are the elements, and or we can say universal set. So crisp C is nothing but x says that x belongs to x. So if these we term this as small x, so this x is belongs to capital X. That means this x is either belongs to x or it is not belongs to x. That is the role of a crisp. We have seen in the diagrams. So with respect to the crisp, so we say if this is x, x is a color. So if this is a color, and if this one is given as capital X, so x is this small x belongs to this x, or it is not belongs to. If it is outside, this is not the actual object. So the in this way we defining that particular terms. So we 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 term that particular representations in terms of a representations in terms of a x belongs to capital X. Now when we take the in terms of a function crisp set x, since capital X we are denoting what is capital X, this x may be either 0 or 1. That means if anything is inside this one, that is called as 1. Anything outside this one is 0. So everything, all the element x1, x2, x3 up to xn is depending upon how much how many elements are within that in that x. That is what we termed as a 1. And other than that, whichever element is outside this one is termed as 0. So the crisp set function fa of x. So we say the crisp set function f of a given set A. So A is a set and its crisp set A of element x is denoted by the universe of discourse, which is having two elements 0 or a 1. So fa of x is equal to 1 if x is belongs to A. That means if this is A, x is belongs to A, and if anything is outside this A, then x is not belongs to A. That is what we mean to say. 1 means x is belongs to A. If I am defining this x is equal to A, capital S, that is what is A here, capital A. Capital A and capital X is same as we termed as a universe of a discourse or a given crisp set. In the classical set theory, the crisp set A of x is defined as function fa of x is called the characteristic function of A. So this you keep it in mind that in the classical set theory, the crisp set A of x is defined as function fa of x called the characteristic function of A. So this is what basically we have seen in the under the fuzzy logic the case with respect to the basic of a crisp set theory. So one is universal set, Venn diagram, cardinality, null set, single tone, power set, classical set, crisp set. So when we talk about a crisp set is same as classical set. So that you keep it in your mind. So classical set A of x is defined as fa of x. So this function is a notations which is most often we are going to use it in the subsequent discussions. With this I conclude. Thank you.